Example 3, calculate the limit as x approaches infinity of the natural log of x divided by the cube root of x. Okay, so the first thing we do is check the numerator and denominator as far as the limit is concerned as x is approaching infinity. So as x approaches infinity of the natural log of x, we see that that's going to be approaching infinity. And the limit as x approaches infinity of the cube root of x is also approaching infinity. So what we want to do is we want to apply L'Hopital's rule. So if we want to apply L'Hopital's rule, we have the limit as x is approaching infinity of the natural log of x divided by the cube root of x, which is the same thing as x to the 1/3. And so therefore, we want to apply L'Hopital's rule. So when we want to take the limit as x is approaching infinity, the derivative of the natural log of x is 1 over x. And the derivative of x to the 1/3, which you can see over here to the right, is 1/3 x to the negative 2/3. Okay, so if we take the limit right now as x approaches infinity of 1 over x times 1/3 x to the negative 2/3, okay, this is now an indeterminate type of 0 over 0. But instead of applying L'Hopital's rule a second time, as we did in the previous example, we're going to simplify this expression and see if a second application is whether it's necessary or unnecessary. So let's see if we can simplify this expression a little further. Okay, so technically we have 1 over x, and this is divided by 1/3 x to the negative 2/3. Okay, so we're going to take the reciprocal, so this becomes 1 over x times 3x to the positive 2/3 over 1. So if we multiply across, we get 3x to the 2/3 divided by x. Now this has an exponent of 1, so we get 3x to the 2/3 minus 1, which is the same thing as 3 over 3. So we get 3x to the negative 1/3, which then becomes 3 over x to the 1/3. So what we end up getting now is the limit as x is approaching infinity of 3 over x to the 1/3. Okay, and then let's go ahead and rewrite that as a radical. So the limit as x approaches infinity of 3 over the cube root of x. So now when we apply that, we end up getting 3 over infinity, which we know is going to equal 0. Now that we found the limit, let's just check and see what this would look like if we would graph this function. Okay, so if we wanted to graph this function, we have the natural log of x, and we're going to divide that by the cube root. So the cube root of x. Okay, and then let's go ahead and minimize our scale here. So we're going to go from, let's say, 0, let's go to 10,000. And then we're going to go from negative 1 to 2. Okay, so let's go ahead and look at this graph. Okay, the reason why I chose 10,000 is because we can keep going and going and going. So the graph of this function, okay, we have discussed previously the slow growth of logarithms. So it isn't surprising that this ratio approaches 0 as x is approaching positive infinity.